This lecture is for AP Chem, Chapter 4, which is a review of chemical reactions and stoichiometry. So first, a little bit about water. We call it the common solvent or the universal solvent. It's necessary for reactions that keep us alive, so think about biochemistry. It moderates the Earth's atmosphere. Water has a high heat capacity, so a lot of energy is used just changing the state of water. It's used in radiators, again the high heat capacity. Heats up the water when the engine is hot, and then it cools by releasing that energy to the atmosphere. It's used in nuclear power. If you heat water, it can turn to steam. The steam will turn the turbine, which will help to generate electricity. It's used in hydroelectric power by using the falling water to again turn the turbine to generate electricity. We also use it for transportation. Think about all our stuff that we get on ships. And of course, we need it for food. So water is the dissolving medium. When you look at the water molecule, you should think about its structure, and the angle between the hydrogen bonds is 105 degrees. Remember, these symbols indicate it's a lowercase delta, and that's a partial positive charge. That gives hydrogen a positive side where the hydrogens are, and two partial negative charges by the oxygen. So that's a space filling model, so to help you visualize where the electrons reside. Hydration. Hydration is just the interaction between solute particles and water particles. So if we look at the dissolution of solid in a solution, go to this video.
An ionic solid dissolves in water because of its polar nature. Notice how water molecules become attached to the ions of a sodium chloride crystal in the process called hydration. Positively charged sodium ions attract the partial negative charge of the oxygen in water. A similar attraction occurs between negatively charged chloride ions and the hydrogen atoms, which have a partial positive charge. These interactions loosen the attractions between the ions in the crystal, dislodging them from the crystal. Additional water molecules surround the released ions, insulating them from attraction to other ions.
So I want you to make note that the oxygen is around the cation, and the hydrogen is attracted to the anion. And so the positives are attracted to the negative. When it goes out into solution, it's surrounded 100%. So just another depiction of it. You see your partial charges, and notice the orientation of the water molecule. Positive hydrogen side, partial positive side of the water molecule is attracted to the chloride, surrounds it, pulls it away from the crystal. At the bottom here, you can see the cation is surrounded by the oxygen side of the water molecule, which has the partial negative side. It's surrounded and then pulled off into solution. So salt. It dissolves and breaks up into individual cations and anions, so this hydration allows it to become dissociated. So if we look at ammonium nitrate, when it breaks up into its ions, ammonium and nitrate. And here, the solid is going into water. So hydration is taking place, but the ionic solid dissociates. When that substance dissolves, they become hydrated, which just means they're surrounded by water molecules. Now, water dissolves non-ionic substances too. If there are polar parts of polar bonds in the molecule, let's say polar regions rather than polar bonds. So here we have a substance. If you think about the formula, there's 2 C's. There are 5 H's, counting these guys, 1, 2, 3, 4, 5, and then an OH. So this is ethanol, or ethyl alcohol. Notice one end of the molecule has that OH, which makes it polar. Let's see if I can get rid of that. That end allows it to dissolve in water. The carbon and the hydrogen, they have polar bonds too, but because of the orientation in space, it's a non-polar region of the molecule. Because one end is polar, water is attracted to the polar region. Notice that the partial negative charge on oxygen is attracted to the hydrogen in the polar bond, and that's how ethanol dissolves in water. Now, glucose also has a bunch of OHs attached to it, and water will dissolve in water. How about glucose will dissolve in water because that polar water molecule will be attracted to those OH areas of glucose.